Hi everyone, this is Alice Gao. In this video, I'm going to talk about handling real valued features when learning a decision tree. So far, our decision tree learner algorithm only works when all of the features are discrete. In the real world, however, we're going to encounter datasets where many features have continuous or real values. Let me take the Jeeves dataset and modify it. Instead of having cool, mild, and hot as the values for temperature, we will use actual numbers. You can see the example on the slide. This is closer to what you would see in a realistic dataset. For convenience, on this next slide, I have reordered the dataset based on the values of the temperature. Now, how do we generate a decision tree given that temperature has real values? Let's first recall how we dealt with discrete features. This is the original Jeeves dataset again. Each discrete feature can have any number of values. For example, temperature has 3 values, hot, mild, and cool. Wind has 2 values, weak and strong. Our decision tree learner algorithm, at each step, it chooses a feature and makes a multi-way split using all the values of the feature. If we decide to test temperature, we're going to produce 3 branches, 1 branch for each of the 3 features. Similarly, if we decide to test wind, we are going to produce 2 branches. I've drawn an example on the slide where we decide to test temperature. There is in fact another way of handling discrete features. Instead of allowing multi-way splits based on the size of the domain, we can instead decide to restrict to binary splits only. Let me show you an example. Suppose that we restrict to binary splits only. Each binary split is going to separate out one value of the feature. In this example, we decided to first test whether temperature is hot. If temperature is not hot, then subsequently, we may decide to test temperature again and see if it's mild or cool. You may have observed something interesting here. If we restrict to binary splits, we may test a feature multiple times on one path in the decision tree. In my bottom example, we've tested temperature twice on the leftmost path in the decision tree. In contrast, if we restrict to multi-way splits, then we will test each feature at most once on one path in the decision tree. In some sense, these two options are equivalent. We can always take a decision tree that have multi-way splits and convert it to another tree that only has binary splits. However, these two options do have their pros and cons. With multi-way splits, each split is more complicated, but the tree is shallower. With binary splits only, each split is simpler, but the tree tends to be deeper. Here's another interesting property. If we allow multi-way splits, using the expected information gain metric will cause us to favor variables with a larger domain. The reason for this is that with a larger domain, we can potentially split the data points into a larger number of sets. By doing this, there's a higher chance of reducing entropy. As an extreme example, take a look at the Jeeves dataset and let's consider using day as a feature. Then the expected information gain for splitting on day must be the largest since we have one example for each day and we can make a deterministic decision right away after splitting on day. However, you can see clearly that it doesn't make sense to use day as a feature since the resulting tree does not generalize to any other datasets. I've just discussed the two options for handling a discrete feature. Let's now think about how we can handle real valued features. First option, when we encounter a problem that we don't know how to solve, we can reduce it to one that we already know how to solve. Since we already know how to handle discrete features, we can take a real valued feature and convert it to a discrete one. Here's an example. Take temperature again. Let's define three ranges. If the value of the temperature is less than 21, then we'll say that the temperature is cool. If the value of the temperature is greater than 24, we'll say that the temperature is hot. Otherwise, if the temperature value falls in the middle, then we say that the temperature is mild. This is one way of converting the temperature feature back into a discrete one. There are some pros and cons of discretizing the feature. The pro is that it's easy to do. We already know how to handle a discrete feature. And for a discrete feature, we had two options. Recall that we can allow multiple splits, or we can restrict to binary splits only. The disadvantage of discretizing the feature is that we might lose useful information. It is challenging to figure out good ranges beforehand while we're constructing the tree. Consider the discretization we chose again. What if 28 is the best split point for temperature? In this case, having discretized temperature into the three values, it's not possible for us to split at 28. So this information is lost, and because of this, we won't be able to produce the best decision tree. If we don't pick the optimum discretization, then the resulting tree could become more complex. And the challenge here is that there is often no way to figure out the optimum discretization while we're constructing the tree. For this reason, it's better to deal with the real values of the feature directly without discretizing them. Now, thinking back to discrete features again, we had two options. We can allow multiple splits, which means having a split over all the values in the domain of the feature. Or we can restrict to binary splits only. So for real valued features, is it possible to allow multiple splits? It is definitely possible, but it might be impractical. It's possible because when we have a data set of a limited size, the number of values in the domain of a real valued feature is bounded. It might be large, but it's bounded. So it's possible for us to test on that feature and produce as many branches as the number of values in the domain. However, it's often impractical to do this because the domain of a real valued feature could be very, very large. So we could produce a tree which have a lot of branches, and it's very difficult to use and it's very difficult to interpret. As a result, the better option is to restrict to binary splits only. There are some consequences of this. The tree may become much deeper, and in one path in the tree, we may test the same feature multiple times. We're going to follow this third approach. We will deal with the real valued features directly without discretizing them, and we are going to restrict to binary splits only. Once we restrict to binary splits only, a real valued feature becomes very similar to a discrete feature, except that the real valued feature has a very large domain. For example, for temperature, there are 12 different values. Think about this as a discrete feature with 12 values in its domain. There are 11 possible split points. For convenience, we can define each split point to be the midway value between two adjacent values. For example, between the value 17.7 and 18.3, the average of the two numbers will be a possible split point. How do we choose our next binary split? We will consider all the possible split points, and for each split point, we will calculate the expected information gain and use it to select the next binary split to perform. So far, this is a straightforward generalization of how we deal with a discrete feature. We are testing a real valued feature as a discrete one with a large domain. However, if the domains of the real valued features tend to be very, very large, then we're essentially doing a brute force search every time we're choosing a split point, and the search space could be very, very large. In the next video, I will talk about a heuristic. Although using the heuristic does not guarantee that we will find the optimal split, it will help us to greatly reduce the number of split points that we need to consider when we're choosing the next binary split to perform. That's everything for this video. After watching this video, you should be able to do the following. Explain the two different approaches of testing a discrete feature, allowing multi-way splits and restricting to binary splits only. Explain the three ways of handling a real valued feature, and explain why we decided to go with the third option, which is restrict to binary splits only. Thank you very much for watching. I will see you in the next video. Bye for now.